Have you ever wondered how we can animate materials in Unreal Engine? In this video, we're diving into the time node. It's one of the simplest yet most powerful animation tools in the material editor. I'll show you what it is, why it's useful, and how to actually use it in our materials. So let's do it. The time node. Right-click in the material graph and search for time. This is the node we'll focus on in this video. It has no inputs, one output, and these settings in the details tab. I'm gonna go over them in a little bit. This section here adds a description to the node. All the nodes have it. We can also right-click on the node and add the description from here. So what does it do? The time node is used to add the passage of time to the material. Let me show you what that means. Drag out of it and search for debug. I'm gonna use the debug scalar values function. So let's add it, connect it to the base color input, and let's set the preview mesh to plain. Now this number here is the number of seconds since I've opened the editor, and it uses the global timer from the engine. As you can see, the time output is in seconds. Save the material, and let's assign it to the cube in the level. And click on play. We can see that it starts from 0. By default, when we pause the game, time stops. On the time node, we have this option to ignore pause. Let's enable it and save the material. Press play and press Shift and F1 to have control over the mouse. And now let's stop it, and as you can see, time is still running. This can be useful to animate some materials while the game is paused. For example, keeping animations active on UI elements like pause menus or loading screens. The other option is to control the period of time. It can help create loops. For example, if I enable it and set it to 5, we can see that time runs up to 5 and then restarts from 0. Let's connect the time node to the emissive color input and save the material. You can see that the cube is lit up. It's because the time value is so high. If we play the game so it starts from 0, you'll notice it gradually lights up. That's time in action. Let's actually edit the material so we can better see it. Hold M and click to add a multiply node. And let's multiply it by 20. Save the material. And now click on play, and as you can see, it is gradually lighting up. The time node can be useful to create all sorts of animated materials. We'll create some of them in the examples part of the video. Before creating the examples though, let's go over some considerations. Considerations. We can use the time node with sine or cosine nodes to create looping effects. The output of these two nodes oscillates between -1 and 1, so it's perfect for creating back and forth changes like pulsing effects. We can also use it with the frag node. The output will loop between 0 and 1, just like when we enable the period option and set the value to 1. We can use a multiply or divide node to control the flow of time. For example, if we divide it by 2, the speed of time becomes half. We can see it better if I divide it by 10. And if we multiply it by 2, the speed of time doubles. Again, let's multiply it by 10 so we can better see it. We can use the add or the subtract nodes to offset time. For example, now it is 4500, and if I add it to 200, it becomes 4700. Also, by default, it is 4500 again, and if I subtract 500 from it, it becomes 4000. When we multiply or divide the time node, we are actually affecting the total amount of time too. For example, here the time period is set to 5. It means that it goes up to 5 and then resets. But if we divide it by 5 and connect it like this, now not only the speed is divided by 5, but also the period is divided by 5 too. It goes up to 1 instead of 5 and then resets. So the period is being divided by 5 as well. The same goes for multiplying the time node. For example, if we multiply it by 2, now it goes up to 10 at a double the speed. We could still create the loops that we want. We just got to do a little bit of math before that. And the thing with the period option is that we can't access it through the material instance. For example, if we want to have a 0 to 10 loop at 2 times the speed, we should set the period to 5 and then multiply it by 2. Or if we want to have a 0 to 10 loop at 3 times the speed, we can do it with decimal numbers. For example, set the period to 3.333 and then multiply it by 3. Now we have a loop that almost works the way we want. A better way to both be able to control the speed of time and create loops is to use the nodes such as sine, cosine and the frac node. Let's add the frac node. Whatever we feed into it, the output will be the decimal part. So it will be between 0 and 0.9999. So we kinda have a number that goes between 0 and 1. Let's connect them like this. Now, we can add a multiply node before the frac node to control the speed of time. For example, let's hold them and click to add a multiply node, connect it. And now if I multiply it by 5, the speed of time is now 5 times more, so it takes 0.2 seconds to go from 0 to 1. And if I set the b value to 0.1, we can see that now it takes 10 seconds to go from 0 to 1. The same way, we can add the multiply node after the frac node to control both the time and the loop. So let's connect them like this. And set the b value to 10. Now the loop goes from 0 to 10 in 1 second. If we want to have a loop that goes from 0 to 10 in 10 seconds, we can connect a multiply node here to control the speed. Let's do that. And set the b value to 0.1. This way, this multiply will balance the speed of time, and this multiply only affects the loop. We can set the first multiply to 0.2, and now we have a 0 to 10 loop that goes in 5 seconds. You can basically do it both ways. Me personally prefer using the frac or the sine or the cosine nodes. Based on the documentation, on mobile materials, the period computation is performed on the CPU at full precision, whereas on the GPU it will run at half precision. It means that it will potentially have issues on periods longer than 1 minute. That's nothing to worry about though. As I said before, we mostly use the frac or the sine or the cosine nodes to create loops. Time node is not frame dependent. It's based on actual real world time, which makes it great for consistent animations. Next, we're gonna create some examples. But before that, if you're finding this helpful, like the video and subscribe. You can get early access to videos and download the tutorial project files, including the project file of this video, by becoming a supporter on Patreon. And if you want to stay connected, join our Telegram and Discord communities. All the links are in the description. Examples. I'm gonna use some other nodes beside the time node to create the examples. If you're unfamiliar with any of them, check out the material nodes playlist on my channel. I have a brick material. Let's add both motion and distortion to it. To add motion, we simply need to use the panner node. So hold P on the keyboard and click to add it. Connect it to the UV's input of the texture. And let's set the speed in the y-axis to 0.1. Save the material and assign it to your mesh. As you can see, now it starts moving. The panel node is using time by default. We can connect the time node here or not connect it. It works the same. But in order to manipulate the time and add distortion, we should use the time node. So let's add it. I'm gonna use the Perlin noise from the starter content. Hold T on the keyboard and click to add the texture sample node. And here, let's search for Perlin noise. Here it is. Let's add it. To have distortion, we should add the noise to the time node. So hold A on the keyboard and click to add the add node and connect them like this. I'm gonna use the G channel. Now connect the add node to the time input and save the material. Now we have distortion. What the noise texture is doing, it's adding a value to time. It's actually offsetting time. So now based on the noise texture, in the brighter areas time is more offset and that creates the distortion. Hold M on the keyboard and click to add a multiply node. Connect it after the texture like this. And for the B value, let's add a scalar parameter. Hold S on the keyboard and click to add a scalar parameter. Let's name it distortion amount. Set the default value to 1 and connect it like this. Save the material. And now we can control the distortion amount. For example, if I set it to 0, we don't have any distortion, and if I set it to values more than that, like 2, we have more distortion. I'm gonna use the radial gradient exponential function for this example. So let's right click and search for it. Add it and connect it to the base color input. Let's also set this preview mesh to plane. As you can see, one of the inputs is for radius. I want to animate it using the time node. So let's add the time node and run it through a sine node. I want it to become larger and then smaller and loop between them. Right now it goes from -1 to 1. That's what the sine node outputs. Let's add an absolute node so it's only positive values, and let's also divide it by 2 so it goes from 0 to 0.5. Now I don't want the radius to be 0 at any time, so let's add it to a small value like 0.05, and now it goes from 0.05 to 0.55. Let's connect it to check it. Also enable real time here to see how it looks. To control the speed of the animation, we should multiply the time node. So after the time node, hold M on the keyboard and click to add a multiply node. Connect it like this, and let's add a parameter for the B value. Hold S on the keyboard and click to add a scalar parameter. Let's name it speed and set it to 1. Connect it like this and save the material. Let's assign the material to this plane and set the speed value to something lower like 0.3. Duplicate the previous example and open it. Let's disable real time here for now. Disconnect the radius input. Hold Alt and click on the wire to disconnect it. Move these nodes here to make some room. Hold 1 and click to add a constant. Let's set it to a small value like 0.1 and connect it to the radius input. The center position input can control the position of the gradient. Its default value is a constant 2 vector which is set to 0.5 and 0.5, and it's the center of this plane or the UV map. Hold 2 and click to add it vector 2, set it to 0.5 and 0.5 and connect it to the center position. As you can see, the position doesn't change, but if I set the x value, for example, to 0, you can see that the gradient goes over here, and if I set the y value to 0, it will go over here. In this case, x and y control the u and the v position. So now we can use this information to animate the gradient. So let's delete these two and get back to the time node. I'll divide it by 5 and add 0.1 to it, and let's connect it to the radius input. So now when we divide it by 5, it means that it will go from 0 to 0.2, and when we add 0.1 to it, it means that it will go from 0.1 to 0.3. For the center position, I'll use the output of the sine node. So let's drag out of it and search for append vector. I want to animate it in the U axis, so the sine node should be connected to the A input. For the B input, I'll hold 1 and click to add a constant, set it to 0.5 so it's in the center, and connect it to the B input. Connect it to the center position input, and let's enable real time. Now the sine node goes from -1 to 1. That's why the gradient disappears. To bring it between 0 and 1, we can do a little bit of math. So drag out of it and add an add node. Let's add 1 to it and then divide it by 2. This will bring it in the 0 to 1 range. Now connect it to the center position. Oh, I made a mistake. I should do it only to the output of the sine node. So let's disconnect this, move it here, and then connect the sine node to the add node and connect it to the A input of the append. Then connect the append to the center position input, and this is the result. I wanted the radius to be at its minimum when the circle is in the middle. You could also directly connect the absolute node to the append node, and this would be the result. But I didn't want that. Hold T on the keyboard and click to add a texture sample node. Here, let's search for noise 01 and add it. From here, make sure that engine content is turned on. Add the time node and connect it to the sine node. Hold A and click to add an add node, and let's add the noise and the sine node together and connect it to the base color. Here's the result. Hold S and click to add a scalar parameter, and hold M and click to add a multiply node. Connect the time node and connect the scalar parameter to the B input. Let's name it speed, set the default value to 1 and save the material. Now we can control the speed of the animation with this parameter. This is what it looks like if I set it to 0.1 and 0.5, 1, and this is 2. Let's set it to 0.3. Hold T on the keyboard and click to add a texture sample node. Here, search for brick. And let's add this brick texture from the starter content. connect it to the base color input, and let's also set the preview mesh to the plane. Select the main material node and set the blend mode to masked. Now we should add the animation for the opacity mask input. Add the time node and the sign node. Hold T and click to add a texture sample node, and let's set it to the Perlin noise from the starter content. Add these two together. Hold A and click to add the add node. To control the speed, again hold M and click to add a multiply node. Connect it like this and hold S and click to add a scalar parameter. Name it the speed. Set the default value to 1 and connect it to the B input. Now connect the add node to the opacity mask input, and this is the result. Now we can control the speed of the animation with this parameter. Let's set it to something lower like 0.25. We can use the same principles to animate this sphere. Add the time node and the sign node and connect them like this. Hold M and click to add a multiply node and connect it right after the time node. Hold S and click to add a parameter, name it speed, set the default value to 1 and connect it to the B input. Now we should use this with the world position offset input to control the movement animation. I want to only animate it in the Z axis. So let's right click and search for append many and add this function. Connect the RGB output to the world position offset input, and for the R and the G or X and Y inputs, let's hold 1 and click to add a constant. 0 is fine. Connect them like this. This makes sure that there's no offset in the X and Y axis. The sign node outputs values between -1 and 1. I don't want negative values, so let's bring it in the 0 to 1 range. Add 1 to it and then divide it by 2. Now it's in the 0 to 1 range. In terms of world position offset, it's 1 centimeters max. That's not really noticeable right now. So let's multiply it by another value. Move them here to make some room. Hold M and click to add a multiply node and connect it like this. Then connect the multiply to the B input like this. For the B value, let's hold S and click to add a parameter. I'm gonna name it max offset range. Set the default value to 1 and connect it like this. Save the material and let's assign it to this sphere. Now by default it only offsets between 0 and 1. Now for example, if I set it to 100, then the object offsets between 0 and 100 centimeters. Now I can control the speed of the animation with this one. For example, if I set it to 0.4, it slows down, and if I set it to 3, it becomes faster. Once you understand how to manipulate the time node with math or textures, you can make nearly any kind of animated effect. If you like these kinds of videos, head over to my Patreon. Becoming a supporter gives you access to my videos before anyone else. You'll also have access to the project files. And that's it. Click here for more Unreal stuff, and thank you so much for watching. Massive shout out to my patrons for making this possible. Like this video, subscribe, and join our communities. If you have any questions, leave them in the comment section below. So, see you in the next one.